This video, I'm going to go through some of the questions that came in from the lessons. I'm going to start with honors and we'll look at the B and D lessons. So these were questions from last week's lessons on Pythagorean theorem and the distance formula. And then I'll move into BE questions. So feel free to skip or pause or turn off the video as I go through questions that pertain to you. First question was, for problems where you have to state the hypotenuse, and then solve if the numbers equal a right triangle or not. Is the bigger number always the hypotenuse? And the answer to that is yes. The hypotenuse is always going to be the largest of these. And we'll figure out, is there a suggested way to figure that out if it's not as obvious? And the hypotenuse is always across from the right angle, and it will be the longest side in this diagram as well. Is there a trick to finding what is the hypotenuse? So here's an example. Let's say I had, let me undo this for a second. Let's say I had root 10, 2, and 4. And maybe this isn't the most challenging example, but it's maybe not as clear what is the hypotenuse. So first off, I could estimate this. I know this is close to the square root of 10. Sorry, this is obviously close to the square root of 10. This is close to the square root of 9. The square root of 9 is 3. So this is going to be close to 3. So I already know it's going to be actually, as far as order goes, in the middle. And this is the longest. Another way is that I could square these. I don't normally do that randomly with numbers and with expressions, but I know I'm going to build an equation anyways. So if I'm not sure what the biggest is, I could square them and then compare them. And I can also get confirmation there that if this was the biggest, then when it's squared, it should still remain the largest or the biggest. So this is definitely C. So that is, the suggestion is estimate or square them and then look at them and adjust as needed. I'm going to just delete these as I go so I make sure I answer all these questions. So is the hypotenuse always the longest side? We answered that. And then some other questions here. Slide 8, this was from the 6-2B lesson, so I'll look at that. And we also have a question that says, when we have A, B, and C, and we have fractions, is it better to convert it to a decimal? I would say leave it as a fraction. And if it's even as a decimal, I might even convert it to a fraction. Fractions work better with square roots, and square roots are a key part to Pythagorean theorem and the distance formula. And I think I have some examples of this where with 6-2B slide 8. 6-2B slide 8, we have a right triangle, and it is 3/4. 1/2 and x. All right, so we will solve this. It will be 1/2 squared plus x squared equals 3/4 squared, which is 1/4 plus x squared equals 9/16 minus 1/4 on both sides. So you can see that I'm squaring the whole fraction. So using parentheses there is really needed. And you need to make sure that you're squaring the numerator and denominator. This is 4/16. So that will be 5/16. And then I'm going to square root both sides. And that will be root 5 over 4. It rationalizes itself. And so you can see I kept that as fraction. So that was slide 8. Let's see if we got what most people got. Cool. And then let's go back to our questions and see. Next is 6-2D, number 16. Let's look at that. Slide 16, 4, 2. Six comma -2/3. All right, so our distance is going to be the square root of 4 minus 6 squared plus 2 minus 2/3 squared. I'm kind of doing this whole thing every time, even though I could do some scratch work and maybe make it disorganized. I'm trying to keep everything organized, keep the square root there every step of the way. and I do have an error here, right? 4 minus 6 and 2 plus 2/3. And 2 and 2/3 will be 2 times 3 is 6. Plus 2 is 8/3. And now we've got negative 2 squared is 4. 4 over 1. And this will be 64 over 9. We'll multiply this by 9 to get a common denominator. We've got 36 plus 64 over 9, which is square root of 100 over 9. We'll square root. I'm kind of going overboard on this last few steps. I could probably skip through this a bit quicker. 10/3. So you can see how I kept that as fractions. Apologize for that error right in the beginning there, but I did catch it. It was 2 minus negative 2/3, so 2 plus 2/3. Let's see if that's what most people got. Cool. Let's go to some of these other questions and maybe kind of clear out some of these questions that I did. So I answered these. Hopefully that was helpful. There was a question about this triangle and the distance formula and splitting it up. And the question stated, it was an interesting question. You can split the triangle in half and see it as a 2 by 5 triangle. And then I'm getting a perimeter of 14, which was not the answer that we actually want. So that's kind of understandable though, because you can break this up. And so this is 2 by 5, and this one's 2 by 5. But the perimeter of the original triangle is going around it like this. It is not including this inner part. So this is 2, and this is 2, which is 4, and that's why that was in the answer. But we need to find this length here using the distance formula and double it, because there's 2 of those. And so breaking it up might be somewhat helpful. I think that's a bit more helpful for the area. It's not as helpful for the perimeter. So the perimeter, if I clear this out, is finding this length, and finding this length for the original triangle. And if it's broken up or not broken up, we should still have the same perimeter. It might have been actually finding the perimeter or part of the perimeter of the right triangle there. All right, and so that was that question. Yeah, there was a typo at the start of the D lesson where I kind of flip-flopped accidentally. It was not on purpose. I did flip-flop the placement of C and B at some point where it went, might have been right around here, or maybe here. Yeah, I don't remember exactly where it was, but somewhere in here, I might have changed the order of some of these letters. And I now don't know where it is, but the question was that on purpose? I believe B and C should be swapped. They should be. That would make the answers make more sense. I wasn't intending to do that. So thanks for catching that. A couple other people pointed that out. And now I'm going to go to the E questions, and I'm going to answer slide 23 from 5.1b. And this will also answer this question, which is how to solve to find the equation. So we'll look at slide number 23 from 5.1b. Slide number 23 had a line with a slope of 5 and a passage through point -8, 0. Slope of 5 and passes through the point -8, 0. So we will, first of all, the setup is that this goes there, and this goes there, and X goes there. So the setup is we plug everything in. Then we have an equation, and we are going to solve or isolate B. If you'd rather flip this whole equation, if that's helpful, you can. 5 times -8 is -40 plus B, and we'll move the 40 to the other side. And that's what is known as like solving for the equation of this line. And we put this together to be y equals 5x plus 40. If you look at the 5.1c Desmos lesson, you'll see some videos where I do this again. So this keeps coming up. So hopefully by the end of the C lesson, it's making a bit more sense. And keep submitting private comments in Google Classroom or posting comments in the Desmos activity at the end if you have a question, or feel free to email me to get some clarification on the lessons and the homeworks.